All right, everyone. Welcome to this week's presentation of DBA Fundamentals Group. This time it is Magnificent 7 and Beyond, Intelligent Query Processing in SQL Server by Tayeb Ali. Today is May 30th, 2023. Welcome back, everyone, from, if you're in the United States, welcome back from your long 3-day weekend. Hopefully everyone's able to join us from that. If not, I am sure you are watching this on YouTube later on, so all is good. In the top right-hand corner of the screen, you should see the 3 leaders of the DBA Fundamentals Group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. Beside our names, you can see each of our Twitter handles. If you, for any reason, need to get a hold of us, that would probably be one of the easier ways to do that. So just reach out to us at any time. Ask any questions you may have. Below that, you'll see the various social media places you can get hold of anything with DBA Fundamentals. Top thing on the screen is a meetup, where most of you probably got hold of this information to log on today to get this wonderful presentation. You can also see any of our upcoming presentations, so be sure to sign up for as many of them as you can today. Below that is our website, dbafund.org, where you can see all of our upcoming presentations, our past presentations. Reach out to us for all kinds of goodness. That's always fun on there. Below that is one of my favorite websites, period, dbafundtube.com. You can see all of our past presentations, and be sure to actually like and subscribe to us so that you can see all of our presentations when they become available. Always a good thing to see all that goodness. Below that is our Twitter, our Slack handle, our Slack channel, and our LinkedIn groups. So if you want to reach out to us on social media, you have a plethora of ways of doing so. As always, our session is being recorded and usually be available within 1 to 2 days. So be sure to check us out on dbafundtube.com to see when it is. And like I said earlier, if you like and subscribe, you'll get the actual link to it as soon as it is available. So you don't have to check our website 30, 40 times a day like most people should. Just as a reminder, please be sure to turn off your camera and mute yourself when watching this presentation, just so we can all focus on Tab and be sure to focus completely on him. Also, be sure to type any questions you have into our chat window. I'll be monitoring the chat so that we can send them over to Tab so that he can actually watch and answer them live and live and on screen. And with that, I have Tab's abstract showing all the goodness he has, but I am positive that he'll give a much better description than I ever could. So with that, over to Tab.
Thank you, Kevin. I'm going to share my screen. Just let me know if you can see it.
We do.
Okay, great. So thank you, everyone, for joining. If you're in East Coast, it's your lunch hour. And I do not take this lightly that, you take off time from your lunch hour and joining. If you're in West Coast, probably early for you. And if you're joining from overseas, I don't know. So whatever it is, I do thank you for joining, and thank you, Kevin, for the opportunity. And let's move. So I am not going to talk about myself and my Azure certifications. I just want you to take a note of my contact, because this is going to be a fast paced session, and I'll explain why. And if you need to follow up with me, just remember the word SQL Worldwide, and you will be able to find me in multiple places. And it doesn't matter whatever way you contact me, I'll make sure that I answer your question within a few days. And I follow all this, so email through my website, LinkedIn, Twitter, all of this work. As long as you can get a hold of me, that's the main point. So let's get back to the talk. Anytime I give a talk, I first want to always ask this question that why should you listen to this talk, right? I know all of you probably read the abstract or at least half read it. And if you're working with SQL Server from 2017, you're probably hearing all these words, intelligent query processing, adaptive query processing, and all that. So there is some history to it, but I'll go back to that a little bit later. So first I wanted to focus on what happens to SQL Server when we submit a query. And when I say we, I'm going to turn off my camera. I'll turn it on later on during Q&A. And please put your questions in the chat. Kevin and I'll be monitoring it. I'd rather answer your questions, because if someone has a question, it means 10 other people have that same question. They're just a little bit shy to ask it. So ask it here. I'll pause and I'll answer those. If it's a logistic question, Kevin will take those. All slides and the demo code will be available to all of you, and you can download this from my GitHub page. It's not loaded there yet. It's not refreshed. I'll get it done by tomorrow. So coming back to the question I was asking, what happens? And when I say we submit a query, I mean, it doesn't matter if it's from SSMS, from an application or whatever, what happens behind the scene. So as soon as we submit a query to SQL Server Engine, and this is not version specific, it goes into a phase that we call parsing. So it goes and create a tree and see if our query makes sense. And if the query makes sense, at this stage, it even doesn't check if those tables are or the objects exist or not. It's just checking logically whatever T-SQL you typed, does it make sense? And once that phase is done, and if it passes, it moves to the next phase. And the next phase we call is a transformation. And in the transformation phase, Query Optimizer produces equivalent variation of the tree that I just talked about. And what does that mean when I say equivalent variation? Equivalent variation means it doesn't matter what path I take, what path I traverse between all these trees, I should get the same result set. So I might be going into different path or different way. It can be a longer or shorter path, but that doesn't matter. The result set needs to be the exactly same, right? Whatever the result set was asked, because you cannot have two different tree path and then you're getting two different result set. That'll be a disaster. After the transformation phase, then it gets to cardinality estimation. And this is very important. And Microsoft from SQL Server 7 till SQL Server 2014, Microsoft had a single cardinality estimator engine or cardinality estimator. And then in 2014, there was a rewrite of that. And you can still go back to the legacy one if you want to. There are hints that you can use if for some reason the new cardinality estimator is not giving you or your query is getting regressed. Now, with the cardinality estimation phase, how does this estimate work, right? So there are a few sources on that. Some are, once you create an index, you probably heard about histogram. It goes to the histogram and looks at that. Even with the histogram, I don't know if all of you know, doesn't matter how big is your table, you only get 200 records in your histogram. So even if you have a table with say like 20,000 record or 20 billion record, histogram only holds 200 data points. And in between there is an estimate it makes. And I have a totally different talk about that, explains all that. And sometimes you do not have an index, right? So there's heuristics, there's built-in algorithms within the engine that the calculation works. And once you do that, the estimation phase is done, then it compares the cost based on that estimate out of all the different trees or all the different paths. And the SQL Server choose one of the plans. And does SQL Server doesn't try to choose the best plan, because if it tries to do all the permutation combination and get through all the plans that's possible and try to calculate the cost, the compilation time will be way more than the execution time, right? And that can be a problem, right? That can slow down things. Now, once SQL Server finds a good enough plan, it puts that plan into the cache. And then query get executed using that plan in the cache. Why does it put in the cache? So the next time, if you submit the same query, SQL Server can avoid the first 4 steps that you see here. It can straight see the plan is in the cache. Yes, execute the query using that plan. Giving you an example, right? If you go to a doctor's office, we all go and check in, right? What do they ask you? Last name, date of birth, right? Everyone, last name, date of birth. So does it need to make the plan every time and compare cost and all this? No, it's the same thing. It can take the same tree. It knows that it works. But historically, once a plan is in the cache, SQL Server keep using it, even though it is not optimal sometime. And why it's not optimal? We all know that our data is not evenly distributed oftentimes. So once the query is called for the first time, you might be passing a value that probably qualifies, say, 1,000 record. Next time, you might be calling with another value, another parameter value that might qualify for 1,000,000 rows. But it is still going to use the plan that have in the cache for 1,000 records, right? That might be doing a seek, and now you need a scan because now this one qualifies for 1,000,000 record. SQL Server sees that, right? SQL Server knows that, hey, this is not optimal. But historically, SQL Server didn't have a way to self-correct itself. And so I'm going to go a little bit further here. And the estimation can go wrong for many, many different reasons, right? Your statistics may be out of date. And yes, I'm not going to get there because that itself can be a talk. And there are also some built-in limitation with SQL Server Engine, like we know, multi-statement table valued function, table variables, they all have hard-coded number of estimates, right? And it was 1 pre-2014. Some of this has been increased to 100. Is still not enough. So we know there are limitations, within this. And so for all of this, the estimation can go wrong. And then you can see if the estimation goes wrong, your costs are wrong. You have a plan in the cache that's not optimal, and now your query execution is taking longer time, using more resource. So ultimately, you are servicing less clients within the same period of time. Imagine if you have a memory grant that you are giving it a lot more memory, what's going to happen? And the other queries are going to wait for memory grant. So now you are putting stuff on hold. They're all waiting. You're going to see different wait types. So SQL Server, finally in 2017, Microsoft decided that let's try to fix some of this. And that's why this intelligent query processing journey started at Microsoft, because it says that, okay, I can see that this is not optimal. Why can't I self-correct myself in the frequent, in the subsequent execution? And then along that came Query Store in 2016. So Query Store, if you're not using it, if you do not know what is Query Store, you should definitely look at it, because Microsoft is heavily invested, one of the awesome tool. And some of this feature that I'm going to show you today is actually built on top of the Query Store. So absolutely, nice thing to look at and learn about it. So if that estimation goes wrong, then what can happen? I'm just going to give you a couple of examples, right? As most of you probably know, there are two settings that we all know. These are server level settings, but in some newer version, you can also set those up at a database level. Based on the query cost, a query can decide if it is going to service some of the operations in parallel or in a serial fashion. And there are two properties that controls that. One is called max stop setting, another one is called cost threshold or parallelism. So if these things get wrong, right now, if a plan was good for just serial execution, now you are executing in parallel, what's going to happen? You are just tying up your schedulers or your CPU for nothing. And if it's vice versa, that you could go parallel, but you're not going because your cost is estimated low, now you're going serial, means it's going to run for a long, long time. Memory grant is the same thing. I just mentioned about that. Excess method. A seek probably will be ideal, but now your estimate is high. Now you're going to start doing a scan, means for nothing. You don't need, and vice versa. Sometimes you probably will do a seek and then do a little bit of a scan. Now all this can get influenced by your estimate. And some of the algorithms, right? Join, if you have I don't know if many of you, if you are in the industry for a while, you probably saw some queries. Suddenly it was running in a couple of seconds and now it is running for hours. What happened? You are probably getting a hash join on a large data set, and now it switched to a nested loop join and is just a screeching halt because it's row by row doing this nested loop join, and vice versa, right? Aggregate, sort, all of this, right? In sort, uh, all sorts ideally should happen in memory because your estimates were wrong and you got less memory allocated, and now you're going to spill to the TempDB. And now some of you might say, hey, I have solid state disks and all this latest and greatest disks, but still you're talking about microsecond versus millisecond between memory and spilling to TempDB. And oftentimes people confuse. They said, is because I had less memory, and it is not. Oftentimes it's actually because your estimates were wrong. It's not that you could not get more memory allocated, and people always confuse this. And in Management Studio or in your XML, you can clearly go and see that what SQL Server is saying, that if you ask me, I could have given you this much memory, but it gave very little because of your estimates are wrong. So these are some of the reasons that that Microsoft came up with this with this feature. So initially in 2017, as you see here, intelligent query processing, and the one that I have in the light, I don't know, like light blue color, these are the features that first came out in 2017. And I'm not going to read this because you can get the slide. And then in 2019, the one you see in the white color, and I circled it, or it's a rectangular thing. You can see this came out in 2019, and the 2022 is the dark blue one now, as you can see. And some of these are actually built on query store. If your query store is turned off, some of this will not work for you. And this is the whole picture, right? After 2022 came out. Now, if I have to talk about all of these, about 12 of these, and show you a live demo, this talk is probably between 2.5 to 3 hours. Of course, we don't have that. So what I plan is I'm not going to go through the slides, but I'll show you at least for one, and I'll share this with you, and then you can consume that. I'll straight go to the demo after a few slides. One question I often get is this turned on by default at instance level, and what can I do? And Microsoft know that for some of your workload, some edge cases, you might not want these features to kick in. Microsoft knows that very well. So what they did is you have a database scope configuration, and in SQL Server 2022 CU4, which came out recently, there are 35 of this. So you can set those 35 things, and I'm not going to go through this. You can run this yourself, select a star from this, and it will give you. You can control these at a database level. Now, some of you might say that, can I turn this on a database level, but I want to control it per query? Yes, you can do that. You can put this in a hint at a query level. And again, in SQL 2022 CU4, there are 31 of this. I checked. So you can do that. For each of these feature, I have put 3 slides. The first slide will talk about the problem that Microsoft is trying to solve. The second slide will talk about how did they solve it. And the third one is, some notes or caution that you should be aware of. And each slide has on the right corner, as you see on the top, have that symbol, which will tell you what slide is this. So if you see this, whatever you're seeing, this is explaining the problem. The next slide will talk about how this got solved, and then some of the things that you should know. On the left side, the feature name is there. And when you say 140 plus, what does that mean? Is a compatibility level 140, which is default for SQL Server 2017 and above, this feature is going to work. And if you're still always thinking about SQL Server major version and not thinking about compatibility level, you should reconsider. Especially if you're in Azure SQL database, there's no concept of major or minor version of SQL Server. It all driven by compatibility level. Microsoft even pushing the vendors to certify their product based on compatibility level, not on major version. Because I can upgrade a SQL Server, I can upgrade a database from 2017 to 2022 and still leave it in 140. Actually, that's one of the recommended path by Microsoft for upgrade nowadays because of Query Store. Because you can run in the old compatibility level, capture everything in Query Store, upgrade it. So now you have your old plan and the new plan in Query Store. That way, if a query regress, you can go and see what's the difference and why did it regress. So I have this about 60, yep, about 62 slides of this. And at the end, I also show you how you can disable some of these features if you need to. And these are just copy paste from the Learn website. Nothing fancy that you do not know, but I just put it there. If someone is new, they have it handy. And these are some of the resources that I used. The first one is, if you just bookmark that one, that will actually take you pretty much anything related to Query Store, intelligent query processing. It will take you to all the pages. That's kind of like your, I don't know what you call this in English, like your content, or that has like bunch of links that will take you everywhere you need to go. And these are the number 2 and number 3 are actually also GitHub page by Microsoft engineers. And all my code actually started from those repos. So I haven't I didn't write anything from scratch. Bob Ward is very open about this. He wants us to copy, paste, and use it when we talk about these features instead of us spending days and days and weeks to write this. So all the demo code that you'll see started from those 2 links, from those 2 repos in GitHub, and then I modified based on what I needed. So I'm going to go to the demo. That's it. I'm not going to go back to slides, but you're going to have this. And like I said, every feature has 3 of this. And you can use this or read more about this. So I'm just going to, this will be a good time to take questions if anyone has any question. Okay, if not, I'm going to move on. Same with the demo code. I doubt very much that we'll be able to, as you can see here, I have 12 of this I lined up. I do not think so we'll be going through all this within the time we have left, but each one has enough comments that you should be able to run it by yourself. But in order to run this, there's a huge setup, which I'm not going to run right now. Of course, I've been running this a few times over this long weekend. This takes about 2 hours to set up because some of these are restoring databases from sample backups that Microsoft provide, and then making some bigger tables just for the demo to work. But each of these has enough comments that you should be able to download, and you should be able to set this up first before you go to do these demos. So I know logically it makes sense to start from number 1, but I'm going to go to number 5 first, because number 5 takes about 20 minutes, and if I show that one, it's going to take most of our time. So there's a feature. I ran this just like an hour or two ago. Okay, so I see this question, Kirby. So I can spell it. I can pronounce your last name properly. So I'm just going to try that. So your Kirby's question is, so you probably wanted to ask the question for demos, do you need SQL 2022? It depends what you want to try. If you want to try all 12, yes, you will need 2022. If you want to try a subset, you will not need 2022. And I'll show you how you will know. So if you see this one, I'm showing, we call it DOP feedback. It's really degree of parallelism feedback. This applies to SQL Server 2022, Azure SQL Managed Instance, and Azure SQL Database, which is in preview. If you want to try this one particularly, if you do not have SQL 2022, if you can spin up Azure SQL Database, it's in preview and you can use it. So read this. I have this comment in every script. There will be scripts that I'll show you that only need 2017. Some will need SQL Server 2019. And some can work in Azure SQL Database. Some features are not yet available in Azure SQL Database or SQL MI. Hopefully I answered your question. So what this one is saying, that if I have a query that is, say, like my max drop, I've set here for 0 and I have 8 core in this machine. So there are operations like a index scan or something can use all 8 CPU, but is that optimal, right? So if this query is running, what SQL Server does behind the scene, it tries to adjust our degree of parallelism and see what is the sweet spot, right? So I already ran this, like I said, it takes about 20 minutes to run this, right, from a CMD file, and I'm going to share this with you. So when I ran this, I also set up extended event trace to capture. And Kevin, is this too small or people can zoom in their own machine? I know some of the softwares allow, some doesn't. Let me know if I need to make this bigger. So as you can see here, it started with 8. And then first he said, okay, you're eligible query for feedback. Then it changed to 6. And then it changed to 4, changed to 2. But when it's doing this, it's also checking other stuff. It's checking, what's the standard deviation of the adjustment, right? About the CPU consumption and duration and other stuff. Then it sees that, when it was trying 2, it decided that no, I was better off with the 4. And if you see here, it provided, provided, validated, provided validation, and then at the end it says I'm stabilized with 4. And you can also see this here. So it started with 8, 6, 4, 2, switch back to 4. And then the average duration and CPU, it's also measuring those. When it sees that I'm stabilizing at 4, what it did in the query store, it put a entry that last good feedback is 4. So now next time when this query comes in, if it's the same query hash, it doesn't have to go this process. Even though my max drop is set to 0, it is going to start running this query with max drop 4 without you doing anything and without you putting any hint. Make sense? So if not, please, type it in the chat and I'll explain. So I'm going to turn this off and then I'm going to start from number 1. So to go back to Kirby's question, for this one, you do not need SQL 2019. You can use SQL Server 2017. Right? And if anybody want to give feedback to Microsoft, you can always send them an email about anything related to intelligent query processing features. They really do watch this this email, and they will respond because they're always looking to improve this. So even though I'm using SQL Server 2022, I'm going to set this to default 140, and I'm going to clear the cache here. And then now, if I turn on my actual execution plan, I run this simple select statement. Now, if you see here something called adaptive join, and I have a join with index scan, another is index seek. Now, in this case, what SQL Server did, it did a hash match, right? Which is default actually during adaptive joins. And take a note of this threshold. This threshold decides from your first input whether it's going to do this tree or this branch or this branch. So let's put some data just for demo purpose. And now I'm running the same query. This was for 360, and now I'm running for 361. Just a different value. And this time, if you look at that, we are getting a nested loop join. And I didn't put a hint, right? And I didn't evict the plan or anything. Why did a nested loop join? Because my threshold is 13.9. And it's pretty close here, if you see. So I don't know if there is a buffer there, based on that, or maybe round it to, I'm not sure. So it's pretty close there. That's why it chooses to do a nested loop join instead of a hash join. And there are algorithms, I put some links in there. You can see how, it decides all this. Now, this was initially released for batch mode, right? If you go here, this was a column store index. And then later on, Microsoft also introduced batch mode on row store, not just on column store. So anytime a row store qualifies for a batch mode, and any feature that is been released for batch mode, you can take advantage of that. So what do I mean by that? And this was introduced in 150, means in 2019, row store on, batch mode on row store. And now if you see here, this is a row store, but it did qualify for a batch mode. And of course, we did get adaptive join. So you do not have to have column store index to take advantage of this feature. One thing you have to be careful is if your cached plan doesn't have adaptive join, the subsequent executions cannot take advantage of that. What do I mean by this? Let's look at a demo. It's going to create a store proc. Again, for demo purpose, I'm going to call this first with 10. That plan is going to get into the cache. Then I'm going to call it with 361 value. And you'll see that both plan, none of these has adaptive join. It got compiled with hash match. I get hash match on the next one too. Now, if I evict that plan, and this is a cool way just to evict one plan if you know what you want to evict instead of clearing your whole cache. Now, if I call it reverse, I call 361 first and then I call 10. Now, the first one was with adaptive join, so the second one is going to take advantage of that. So this is something might not be in your control every time, right? It depends how the app starts and what is the first call. But I just want you to be aware. The second one is a interleaved execution for multi-statement table valued function. So what was the problem here? Before 2014, the estimate was always 1, and 2014 and post, Microsoft has increased this value to 100. And this is still a problem because with the more and more bigger data sets we deal with, the 100 estimate doesn't work all the time. So just going to create a table valued function for demo. And you'll see this pretty much all the time because I'm clearing the cache. And then here I'm setting it up to 130, means a lower compatibility level. And we'll see what happens here. As you see here, it's a fixed estimate, right? But look at the actual number of rows. Because of this, there was a small memory grant, and we have spills to the MDB. If we run the same query in 140 compatibility level now, I haven't changed anything. Right? So this is normal, this is taking a detour. So historically, the way things worked is first your plan is going to get optimized and then the execution will start, right? There is no stop, let's execute a little bit, see what happened, and then we'll resume, right? That concept was not there. And with this feature now, if it sees a table valued function, it evaluates it, see the number of rows or the records qualify, and then decide what, your memory grant and other grants, and then it proceeds. So this is first time that Microsoft took this approach to solve this problem. Memory grant feedback batch mode was introduced in 2017, I believe. Let me look at my drawing again because I do not memorize all this. So yeah, so the batch mode was in 2017, and then the row mode was in 2019. And then in 2022, what Microsoft came up with this is to persist this memory grant feedback into the query store. So the next time it doesn't have to go through that exercise. So let's take a look. I'm going to clear the query store. So we have less data here. Creating a store procedure for the demo. Turn on actual execution plan. And now we are calling this with two different values, 8 and 9. And you see a warning here, and you can see that, I don't know if you can see it or not, there was excessive memory grant. It only used 920 kilobyte, but the memory grant was 67 megabyte. And if you come here, this is, you can also see in the XML plan. It says that this was the first time this query got executed, so I'm not doing any adjustment. But just on the look at the next one, it already know that what happened before, so it reduced too much, and now it used a little bit more. And if we look at the property of this one, it says that I'm adjusting. So now P2022, what happened is it will look what was the last use, and then it will adjust. And then it looks again what is the last use, and it will adjust. So if you keep running 8 and 9, so I'm going to bring one of my slide back. P2019, you're going to see a feature like this, right? Up and down. And finally, in 2022, there's a new feature called percentile grant feedback. So it looks at the last all uses and take the percentage. Now, instead of going crisscross, your grant is going to slowly adjust. To prove that, if I keep running this in a while loop, and we take this in a new query, you see this is 15 meg. And if I keep running this, you'll see it's changing. It's 26. 31. And this is from the query store. So it's constantly updating it. It says feedback valid, right? It's up to 39 meg. So if I go back to, I wrote some notes here. In my test, it settled at 91 megabyte after 19 execution. And if you go to any of these, just pick one randomly here. Now you see that 2022 feature kicked in. It's a percentile adjustment. 57. So it's going to go up to 91 and then it will settle. And at that point, it will get persisted. So next time, if I'm submitting this query, even though, so the problem before was, right, it was not being persistent in the query store. So if the plan got evicted for, there's a whole Microsoft documentation, what are the reasons the plan can get evicted, and itself can be a talk for half an hour, but not getting there. So if your plan got evicted from the cache, next time you come in, this exercise has to happen, right? So now you do not, because this is into your query store. It's saved there, and query store data, as you know, it survives. It doesn't get evicted or anything because it's a part of your database. Next time, it doesn't have to go through this exercise that this has to go here. So you can straight come and start using whatever value get persisted at the end. Yeah, so now you see this 91 is not going to change anymore. And if we come here, I'm just going to stop this. And if I go to the last one, I just want to show you, it will probably say that I do not need to. As you see, you're right, we still have a sort warning, and then at the end, it doesn't have anything. So if we go to the memory grant feedback here, still says adjusting. So I'm surprised it shouldn't. At one point, it will just say, I'm done. I'm not adjusting anymore. And we saw that on the batch mode now. Memory grant feedback on row store was introduced in 2019. So let's look at that. So even if you do not have column store index, you can still take advantage of this, or your queries will, if you're in the right version with the right compatibility level. As you can see in my test, I had how things changed. So as you see here, there's a warning. And if we go to that, it says it's the first execution. So let's execute it again. And this time it should, get a better grants. In my test, it was, 1056. Next time it got, a lot more. So I'm not going to, run more, but you get the point. So by, third or fourth run, you will see that it will see as stable. And next time it is going to use that value if you're submitting, the same a query, that ends up with the same query hash. And again, the same thing you can also look at here in your query store. Yeah, before we had one, now now we have two. One for this one we saw before, and this one I'm just running right now. So you have both values here. It has the query ID and the plan feedback ID. So next time it's going to use this. Okay. So the next one, we're going to talk about cardinality estimation feedback. As I said, Microsoft had in 2014, there's a new cardinality estimation was released. And if you find, before we could do it manually, right? If we, a query regress, we try to figure out what happened. Is it because of the new cardinality estimation or because of the old one? And we, put a hint. Now, starting SQL Server 2022, the engine is smart enough. If it figures out that using the old C feedback is better for you, it will do it automatically. So I also have a extended event trace. To capture this. And so let's look at this live. So I'm just going to run this. Go 15 means run it 15 times instead of being lazy writing a full while loop. And now it says that this query is being analyzed for C feedback. And also, I see that it's also getting into the query store, but pending validation. Anything get done with this new features built on top of query store, like as you saw during the DOP feedback, right? Everything get validated. It just doesn't go change and start using it. It validates and see if it really made any gain. Then it keeps it. If it thinks that no, it did not make any gain, it will pull back to where it was. So you run the query again. And now it's validation phase. Says verification regressed, right? So did not do what it was planning to do. And sometimes it depends on what else is going in the machine, right? I did not expect that. And so I'm surprised that, it did regress, but it can happen. So it is going to revert to what it was. And if it did not, if it passed, the next time it is going to use the whatever cardinality estimation it think was idle for this query. So it's automatic. We've talked about the degree of parallelism feedback I showed you at the beginning because this takes a lot of time, so I'm not going to show that more. So the next one is a batch mode on row store, and this was released in 2019. This was a big ask for the community because people liked batch mode, but of course, as we know, we cannot convert everything to column store index, right? The column store index is not for every data store type, and people had other limitations. So, but people like the batch mode features. So Microsoft, finally introduced this in 2019. And let's look at a demo. So here I'm putting a hint, disallow batch mode, just to show you what happened, how the plan looks like. Taking a little bit longer than I anticipated. So if you have any question on any of those features that I've shown so far, type it in there, and then we can talk about it if we need to. So this is a row store, like our traditional index. And sorry, we got a row mode. Now I did not put the hint, I just took this hint out and left everything as is, same query. And if you look at the query stats, the CPU millisecond and the time it took, you'll probably see a difference between the two. And this one will probably do a lot better than the previous one. Same row store, and you get batch mode. So this is available on 2019 and above. Yeah, I put it here, and in Azure SQL Database too. And if someone wants to see, so YKU, what are the benefits of the batch mode? Totally different talk, but in a summary, this does everything within a large set. So say if something is doing on a row 1,000 times, now that operation can happen on the 1,000 rows in one go instead of doing it 1,000 times. That's I'm telling you in a nutshell. If you send me a thing, I can send you some document from the Learn website. There are a couple of good blog posts also that you can read about, and there are some tests that you can do by yourself and see the difference, so you can appreciate the advantage of batch mode. So now I set the compatible level to 140, which is the default of 2017, and no hint or nothing. And you'll see that we'll go back to the row mode because that proves that you need 2019. Approximate count distinct, and this was released in 2019. And in 2022, there are two more, in the same family, two more functions got released. And those are, approximate percentile. So there's total 3 right now. there's a caution that, you have to know when you're going to use it. If you're counting somebody's money, you probably don't want to use this. If you're looking for analytics type data, looking for trend, this is perfect. So be careful where you use it. And so here I'm just using a count, and here I'm using a approximate count distinct, and here I'm not using the hint at all, right? So there's a margin of error of 2.6%, which is hard coded into the, which is published by Microsoft in the Learn website. So you have to know that what you are dealing with, right, before you start using this. So while this is running, I want to save some time. So you're coming to the end. Did I turn off the plan? I think I did. Shouldn't have done that. Oh no, I did not. Okay. As you can see now, the counts are different, right? And they are within, within the 2.6%. I have a math here. If you want to run this, you will see. But look at the advantage of this, right? If you come here and, like I said, if you're counting people's money, or it's patient data, or you are sending rockets, to the moon, you're not going to use this. Look at the memory grant, 1464 megabyte. Subtree cost is 1024. And look at here, your memory grant is 40 KB. And look at the cost. So if you just need to estimate which can, survive this margin of error, go ahead and use it. Same thing with this. I had this demo on a 20 million table, 20 million row. And I wrote this here. The grant is 842 megabyte. And the subtree cost is this. It's going to take 3 minutes, 10 seconds to run. So I'm going to run this. But compared to this, if you run it with the approximate percentile, and there is some, you have to see how the syntax work with the percentage that you're looking at. This takes 4 seconds. The memory grant is, and you get the pretty much same result set, but the memory grant is 842 megabyte versus 24 megabyte, and then look at the subtree cost. And it's the same with the other one. So these two was introduced in SQL Server 2022, and the other one was introduced in SQL 2019. So there are 3 of these now in the same family. So I only have 2 minutes. I'm going to stop here. As I said, so you still have 9, 10, 11, 12. Now query store hints, it's not part of the intelligent query processing family, but it is built on query store. So I did put some demo here with the Azure SQL database. I gave a lightning talk at one point just on this feature. So I added some stuff here. You can follow this. There is a backpack file you can download. And if you have a portal account, you can set up Azure SQL database and you can run those. And then I have, of course, in between I have 3 that we don't have time, but run those. You have enough comments there. You should be able to follow up. And then if you have any question, comments, that you couldn't follow, then get back to me, and I'm sure I'll be able to answer those, or I'll find out the answer for you. So again, my contacts here, and I want to thank you for spending the time. Hopefully I can send the link to Kevin for my GitHub repo by tomorrow night, and then if Kevin can shoot an email to all the attendees, you should be able to download everything. So I'll hang out here. I know some of you probably have meeting at 1 o'clock. This is lunch hour. So I'll hang out here. If you have any question, comments, I will definitely answer those.
Perfect. Thank you, Tab. We did have one question. What are the actual benefits of putting it in batch mode?
Yes, I touched that when I was talking. So I said, it's a bigger topic. So I told YKU if he or she can ping me, I can send some material. So it's pretty much saying if I have 1,000 record, if I have to do any operation, doesn't matter. Just take a unit one by one on 1,000 record instead of if I can do that operation at one go on those 1,000 set of records, right? So that's kind of in a simple English without going into technical details. But there are resources that I can send that you'll be able to do some tests and see the advantage for yourself.
Awesome. Well, while everybody is typing frantically to put in their last questions and whatnot into the chat, I want to remind you that next week we'll actually have Torsten Stroud talking on parallelism in Microsoft SQL Server here at DBA Fundamentals. Yeah, that's it. Thank you again so much, Deb, for talking through this. I know I've seen a lot of new things in SQL Server 2022, and this makes me even happier. So all good.
Yeah, and thanks for having me. I appreciate the opportunity. I'll try to get everything sorted out in the GitHub repo by tomorrow, and then if you can, share that link with the attendees, that'll be great.
That I will. It will, as soon as you give it to me, it'll always be available on our website, and I'll also send out a thing to the group who here actually came to this meeting about the actual site itself. All good.
Awesome. Thanks a lot. Bye.
Thanks, y'all.
Thank you.